Before starting the next lesson, go ahead and try this warm-up question as a review. I have a table of values. I'd like you to determine whether this is linear or nonlinear. Is it direct or partial variation? And then draw a scatter plot and a line of best fit. So pause the video and try that on your own, and then I'll show you my answers. I found the first differences to be all the same. Because of that, this is a linear relation. If I look at my table of values, when x is 0, y is -1. So this is not going through 0, 0. Therefore, this is partial variation. And when you made a scatter plot, I'm hoping you remembered that negative values of x are on the left. So when we have -2, -7, we go left 2, down 7. -1, -4 is left 1, down 4. 0, -1, 0, down 1, etc. And your line of best fit should go through all the points. This next lesson is about taking a table of values and making it into an equation. Example 1. The table shows air pressure for various heights above sea level. So for heights above sea level, we have different air pressures. What is the initial amount? If you'll recall from a previous lesson, initial amount or initial value refers to where the line touches the y-axis. So in this case, we would be looking at this point on the table of values. So the initial amount or the initial pressure would be 101 kilopascals. That's what kPa means. All right, now rate of change. We've done this before, but I'll just remind you. We can find the first differences, and we can see the rise and the run to calculate our rate of change. So my rise is -2, so every time it's going down 2. My run is plus 500. It's going up 500 every time. So when I do the calculation, -2 divided by 500, I get -0.04 kilopascals per foot. So now let's find an equation. Hopefully by now you're getting comfortable with this format for an equation of a line, y equals mx plus b. X and y are just our variables, m is the rate of change, b is the initial value. So my y value is my pressure, I called it P. My x value is my height, I called it h. My rate of change is -0.004. And my initial value is 101. So there's my equation. In example 2, the table shows the relationship between the number of flyers Bob delivers and his pay. So what is the base pay? Well, it's not on here. Base pay would be, what does he get paid for delivering 0 flyers? We're going to have to do some work and work backwards. So I found my differences between all my values in my table. If I take that pattern and work backwards until I get to 0 flyers, then I'll find my base pay. So if I work backwards, I'll have to go back 50 4 times to get to 0. So I'll go back 2 4 times to get to $10 as my base pay. And what's the rate of change? Well, it's rise over run. So that works out to 4 cents per flyer. Okay, so I've got my initial value, I've got my rate of change. Now I can make an equation. My Y value is my pay. I'm going to use P for pay. So Y equals mx, so m is the rate of change. X is the number of flyers. I'm going to use the letter F for flyers. So Y equals mx plus B. Well, B is the initial value, which in this case was my $10. So there's my equation. What is Bob's pay if he delivers 523 flyers? So what is Bob's pay? We're trying to calculate P. That means we need to plug in or substitute the value for F. 523 flyers goes right there. So when I do the calculation, I get $20.92 here. When I do this multiplication, then I have to add 10, so I get $30.92. So I can answer the question with a sentence. Bob's pay is $30.92 if he delivers 523 flyers. This last example deals with the cost of Slurpees. So the table shows the cost for Slurpees at 7-Eleven. How much will it cost for a 350 milliliter Slurpee? Okay, so I've got the size and the cost in cents. Now you'll notice the 350 milliliter size is not on the table of values. It's somewhere in between these two. So we're going to have to figure out an equation in order to solve this problem. The table of values is written horizontally this time. The first entry is always X though, just like before. So I'm just going to use X to represent the size in milliliters and Y to represent the cost in cents. So to calculate my rate of change, I just have to remember the rise is the change in my Y values, and the run is the change in my X values. So my rate of change ends up being 0.4 cents per milliliter. When I look on my table of values, when X is 0, Y is 0. So that is my initial value. So I can put these ideas together to make my equation in Y equals mx plus B format. So remember, m is the rate of change and B is the initial value. And since my initial value is 0, I don't have to write plus 0, I can just leave it. This is an example of direct variation. So now I can actually answer my question, how much will it cost for a 350 milliliter Slurpee? So that's the size, that's my X value. So I can put 350 milliliters substituted in for X and then solve for Y. So when I do the calculation, I get Y is equal to 140. So I can answer my question, a 350 milliliter Slurpee costs 140 cents. Now, usually we talk in dollars, so I just change that to $1.40. So I have links to 2 handouts for you to work on. One of them is taking a table and making an equation. The next part is solving problems. So if you can do all of the examples that we just went through in this lesson on your own, then you should have no problem with these. But if you do get stuck or if you have questions, let me know and I'll do my best to help.